And now our special speakers, first of all, Hendrik Ebbers. He's the co-founder at Quarkus AG, Germany. He's also the founder and leader of the Dormant Jug, and also an international speaker of multiple conferences, user groups, author of Java FX book in 2014, Mastering Java FX 8 Controls. He's also a Java 1 rockstar and a Java champion and a JSR expert group member. And then we also have Karsten Thoms in here, and Karsten and I met at Eclipse Con last year in October. That's how we kind of get connected and get them over here. I went to your talk, it was real good. So Karsten is the senior software engineer at Quarkus AG, Germany. He's also an X-Text team member and an Eclipse platform committer and Eclipse open source evangelist. So with that, I pass on the microphone to both of you. And again, welcome, and we can't wait for you to start. So
before we start, maybe if you have any questions, you can just put them into the chat, or you can even just ask us directly. You don't need to wait until the end of the session. Just unmute yourself, ask a question. That's totally fine, or put it into the chat. Yeah, okay. So welcome to our talk. Framework Attack, a comparison of Java Microservices frameworks. Before we start, so Mary already introduced us, but maybe Karsten and I can say some additional words about ourselves. So as we both come from Germany. We both live in the same town, which is Dortmund, so we're quite near to each other, and we have from the company we belong to, which is Quarkus, an office here in Dortmund that I created with the founding of Quarkus some years ago. And some words about myself. I'm Hendrik, and I work at Quarkus. I'm one of the co-founder, and I work as a Java architect and a consultant, and next to this I do a lot of things in the Java ecosystem and Java community. So I already did a lot of sessions regarding Java and frameworks and tools of the Java ecosystem at international conferences. Based on this, I became a Java 1 rockstar and Java champion. And what I'm currently doing, maybe not most of my time, but as part-time, is being part of the Adopt OpenJDK technical steering committee, and since some months after it was founded, of the Eclipse Adoptium working group and PMC, where I try to keep Java free and move Java and the Java ecosystem in an open source way forward. Okay, that's enough about me. Maybe Karsten, you want to say some words about you?
Yeah. I'm Karsten. Hi. And I joined Quarkus last year, beginning of last year. So at the start of the pandemic, unfortunately, we did not met us in person so often since then. But at Quarkus, I'm working also as a software consultant and software architect, working for different customer projects. I have a strong background on Eclipse technologies and have built tools and frameworks based on Eclipse for the last 15 years. And I'm also there active in the open source ecosystem of Eclipse, mostly on the Eclipse platform, so what you know of the Eclipse IDE, and also in the area of modeling tools. This is what I'm doing when I have time and spare time to do that. At the moment, I'm too busy with custom projects, if I have time, I contribute with passion to open source projects. So far about me, and Hendrik.
Okay, thanks. What we want to do today, I want to say this evening, but it's not evening for you, right? It's evening for me, but not for you. So today, As already mentioned, we want to talk about microservices and microservice frameworks to create Java microservices. So since the ecosystem is quite big, we want to concentrate on 4 frameworks here, maybe the biggest 4 that are currently out there, which is SpringBoot, Quarkus, Micronode, and the Eclipse MicroProfile. And we want to have a deeper look at these 4 frameworks, where they're coming from, how they evolved within the last years, what benefits they bring, and so on. Next to this, we will have a short look at some additional frameworks, just to show the bigger ecosystem. And then we will, next to having a look at the basic APIs of that frameworks and functionalities, we want to concentrate on the Docker support of those frameworks and what different possibilities you have to put microservices that are based on these frameworks into a container and deploy and run it in the cloud. Yeah, and at the end we will have a conclusion. Maybe you will see that one of the frameworks is better in specific use cases than the other one, and so on. But before we talk about this for frameworks, maybe we start talking about microservices in general. Well, even what a microservice is has evolved within, I don't know, the last years. But when talking about a classical microservice, for a lot of people, it's still something like this, right? You have a small service that has some beans inside that does some small things. And normally such a service is connected to some data storage, which is in a lot of cases a database that, for example, can be accessed by using SQL. And you have access to this microservice that often is done by using REST that in some way is secured by an API or a gateway or something like that. For sure, there are more functionalities that you can have in a microservice, like event-based microservices, things like that. But the classical microservice looks more or less like that. And therefore, when having a look at the 4 frameworks, this is the pattern we want to have in mind. In general, when talking about microservice, I mean, we're at the Java jug here, so we will concentrate on Java today, but microservices is nothing that comes from Java, right? In general, you can create microservices more or less in any language you want. Yeah, I did a mark there, right? So maybe not any language, maybe you don't, or you cannot do that in COBOL, for example, because it's way too old to create microservices. But in any modern language, you can do that. Actually, you can even do this with COBOL because you really can find documentation in the internet how to create microservices using COBOL. This is definitely something I don't want to try, and I hope you never tried and will never try. So let's concentrate on Java today and how to use Java to create such services. Karsten.
Yeah. So, what requirements actually do we have when we think of building microservices? So our expectation is that we would likely create many of them, and maybe with different frameworks. And so for us, it's important that it's really easy to get started with whatever microservice framework we want to use, and we would expect also that we have some kind of stability what they're doing, and they're not changing like all the time like JavaScript web frameworks, and they have one day one framework and next month a completely different framework. So we expect that we want to have some kind of mainstream things that people can learn, can work with, that we have active support by community. We have maintainers that make this framework more rich and mature and more and faster and whatever. And maybe even have professional support on that, so that we can rely on later that we get updates also for older versions that we have still in production. But of course, we can build new services at any time. And Henrik, could you advance?
Yeah.
For microservices, what makes them micro is that they usually will be deployed in containers. That's how they are run nowadays. So we have the requirement that they can run in containers. And when we think of cloud, then it is also important that we have low resource consumption, which is not maybe not the main thing about Java. We want to ramp microservices fast up and down. So that's one important thing that we have to keep in mind when we use microservices with Kubernetes, for example, on which platform. Resource consumption is also a big issue when it comes to the costs of using and serving microservices. Okay, can you advance?
I'm trying to do. Yeah.
So what from the functional side, what do microservices offer us? As Henrik mentioned, usually you have often microservices that are exposing their functionality through REST endpoints. That's one common thing, and the other that we now not concentrate on is our event-based systems. Microservices that connect to event buses and react on events and send things. And of course, we need to somehow to access storages, whatever kind of, be it SQL or NoSQL databases or cloud-based databases, whatever. We want those frameworks that they provide support to connect whatever we need in the cloud infrastructure. Of course, if we expose things, we have to secure that. Those frameworks should possibly provide out of the box means for securing the exposed services. And to exchange data, nowadays, of course, JSON is the way of serializing data, so that we are agnostic of the languages in which the services are implemented in. So we may want to talk to services that are written in Python or whatever, and we should not care when we write our microservices in Java. For us in Java, why do we write them in Java? Because we know Java very well, and we know how to scale that and make it secure, and also Java's strong typing system is clearly a benefit, and the IDE support that we have. So that's one of the reasons why we should write microservices also in Java. So today, as Hendrik mentioned, we want to compare the four most prominent microservice frameworks, and we picked Quarkus MicroProfile, SpringBoot, and Micronode, and we will also have a look at some others, and we try to find some catchy sentence about them. What makes them special? How do they place themselves in the market? What are their unique selling points there? Let's take the first one. When we speak of Quarkus, that's actually the youngest framework that we have here on the cards. Quarkus says of itself it is a breed of the best of breed libraries and frameworks and standards that they compile together. And very prominent is also their focus on support of Gravian. What this means, we will come later in this talk on too. And next, we have MicroProfile, which is a little bit special, and hopefully I do not say anything wrong here because we have Mary here as the host. Yeah, so Eclipse MicroProfile is not really a framework for its own. It is mostly a compilation of standards, and they compile certain standards that are valuable to build microservices like security and data exchange and JSON support and whatever. This they pick together and say, okay, this is our standard. We have different versions of that standard, and there are different vendors that implement that standard. And it's roughly what was Java EE in the past. But taking all this this knowledge, how to build standard-based server-side programs, and with different vendors in the back. Then, of course, we have SpringBoot, which is likely the most prominent Java microservice framework, and it has also the biggest community, and many people are writing Spring Boot services. Spring is quite easy to grasp and to consume, and many people know Spring framework from the past. And Spring Boot is just compiling best of breed there and make it easy to write applications within very few time. And they have a very big ecosystem around it. And last but not least, Micronode. They are more in the reactive area. So they have built this framework from scratch with being reactive up front, which is contrary to Spring Boot, for example. That's not their focus, but this is also because Spring Boot is much older, and nowadays you want to have highly reactive applications, and this is where Micronode was built with a focus on, and also GraalVM. We wanted to look at a little bit at the history of those frameworks and show you how old they are, and which release cadence they have. Can you please advance? Oh, sorry. I forgot that we have the slide.
No problem at all. Should I just take it? Before we have a look at the release history and the general history of the frameworks, one thing that helps a lot to learn how to create applications with the frameworks, or just to bootstrap an application, are the initializers. And today, all of the frameworks have their own initializer. We've just put some screenshots of the web pages here that you can use to easily configure an initial project that you can then download and directly open in your IDE, for example, and start it, or directly build and deploy in a Docker container. In general, you can choose if you want to have a Gradle project or a Maven project, on what Java version your project should depend, on what specific version of the framework your project should depend. For some, you can add additional features, like you want NoSQL support, or you want directly support for, I don't know, a specific security gateway or something like that. This is quite nice to get into the project, to just bootstrap and create an initial project that you can then easily download, open, start, and directly play with it. So within, I don't know, 5 minutes, you have an application, at least a Hello World application, based on the framework up and running. That's quite nice. So whenever you want to try one of those frameworks, this is a good starting point to get your initial setup. I'm just seeing there, sorry for asking this early, but have you done comparison of these frameworks with the new Spring Native framework? Not until now. So we plan to add additional things to the session and to the presentation and keep it up to date. But Spring Native, until now, we have not added it. When we did the presentation the last time, Spring Native was super new and just released at that point. So we haven't added it then. And yeah, until now, we don't have time to add it. But Spring Native is definitely a thing that makes sense to have a look at, especially regarding or against Quarkus and Micronode regarding the CryVM support. Okay. Yeah. So let's have a look at the pieces. I will have a look at the chat, Karsten. Oh, sorry, you want to say something? Yeah, sure.
Yeah, to the slide before, just to conclude here. This is a very nice starting point to create microservices, and it lowers really the bar for newbies to create full running applications. But if you may take into mind that you may want to create many of them, since you build one service by the other, it is also interesting that most of these frameworks offer also REST services that you actually just can call, or they provide also Maven archetypes or just builders, so that you easily can programmatically also create such applications and spin off one by one. Many projects also come to that they build just templates so that you start with new applications that look mostly similar. So that's why I just wanted to conclude with this slide. Now let's look a little bit at the history. SpringBoot is actually it was I think founded 2014. We have this on one slide. So it's the framework with the longest history so far, and as we see, we have different kind of streams, and we wanted to show here a little bit that you have overlapping streams also, so that old versions are still maintained while new versions are developed, and also in parallel. So we see mid of 2020 we had three minor versions which were supported in parallel, and currently you see the people are working on the version 2.5, which is not released yet. So that's the history here. For MicroProfile, it's a little bit different. We do not have really such frameworks that have certain release dates. Here we just have the release of the specification, and you see we are currently in the version 4. Which is the switch to Jakarta EE 8. And with each of these versions, the MicroProfile project defines a different set of standards that makes the applications compliant to the MicroProfile version. And then the vendors like Red Hat or IBM with their application service implement those standards, and they can say, okay, our application server is compliant to whatever MicroProfile version.
Yeah. Maybe a short, because we have some discussion on the chat, and since we are here at Eclipse MicroProfile at the moment, regarding MicroProfile, there was a discussion regarding the initializer or the starter page of MicroProfile, and why you can create a project using Quarkus, for example, at runtime. And we have, on the one hand, MicroProfile, and on the other hand, Quarkus in our slides. So this is, as Karsten already mentioned, the MicroProfile is like spec-based. So what we have in the Eclipse MicroProfile is like a set of specifications that define APIs that can be implemented by different application servers, containers, whatever you want to have. And one thing that implements parts of the MicroProfile is, for example, Quarkus. Other things, like Mary already mentioned, are OpenLiberty, Tommy, Whitefly, Payara, and so on. And it depends on the version of MicroProfile, and you can easily check that on the page, what platform, application platform or application server supports that release of MicroProfile and then can be used to run such an application.
And as the starter page was you mentioned, there you can choose, depending on which Java version you choose and which MicroProfile version you choose, you get a different set of runtimes that support that. Maybe then you see there once Tommy, and with a different MicroProfile version, then you see an option to have OpenLiberty. So yeah, a little bit special. Micronode, here we see it's, was it founded in 2018? I'm not sure.
I think so, yeah.
Yeah. So it's not that old. We see it was developed in a version 1 stream, which was slightly in parallel, so that they supported one version while developing on the other, which changed from the release cadence with the 2.x stream, which is at the moment. So from that on, they just have one minor release after each other, and we see also the that they roughly release one minor version per month, and this is similar to Quarkus. They also have just this this single stream. They took a while until they said, okay, it's now mature enough, which was end of 2019, and we see it was 1 year development until then, and it's really the newest framework here, but it is backed by Red Hat, and they have put quite a lot of power into this framework, so that it's evolving very, very fast with a large ecosystem there, and it's really mature. And we see that right now there's coming up a version 2.x stream, and it's basically, of course, updating to the newest standards. They require now Java 11, like many other frameworks, and also do now that they switch, completely drop the support for Java 8 and say that at least we need Java 11. Interesting there is, it's something special about how Quarkus works. Is you just work with that like you would work with a JavaScript application. So you run it once and start developing it. You do not have to restart. And what they now will add, and which is quite experimental, is continuous testing. So you have some unit tests, and you while you're developing, all the unit tests are executed, and they try to figure out when you change some code, which tests are depending actually on it, and you re-execute only these. That's quite a nice feature that they're trying to build there.
Okay.
I don't know. There's no official release date yet.
So since we're at a jug, we want some code, right?
Yeah. Yeah. Okay. Classical code. So let's look at the typical REST endpoint. That's what everyone does. So basically, you have endpoint classes, and you want to have some service. Like let's take the movie example. We want movie by ID, and Yeah, one interesting thing is, of course, you do not want to deal with serialization. You expect that this is handled by the framework. So if you have some class that builds your models for request and response, then of course this should happen automatically that this is serialized and deserialized to JSON. How this is implemented is different on the framework, yeah, but let's look at that. So, for example, Quarkus and MicroProfile are using the JUXRS standard. I think you all know how to build REST services, and it's completely nothing new. But just let's compare how this reads in different frameworks. Yeah, somehow we give the path under which this resource will be reachable. We say what kind of what kind of data we produced, with what kind of data do we consume, certain methods, are they accessible, with which HTTP method, under which path. We can specify more parameters and bind them to values, and this has to be done automatically by the framework, and we just concentrate on implementing them, these methods to provide our service.
And actually, very important, this is Karsten in the middle of the. Without that one, the code won't compile. Anyway, I think that was my fault when I wanted to add to the note that Karsten is talking about REST. It's not in the note, it's just in the middle of the slide. Okay, yeah.
Okay, now let's look at SpringBoot. So there's some a little bit different. They are providing their own framework, and it's doing the same, but they call this the controllers, and you have to specify which kind of method, which kind of HTTP verb you will use by other annotations. So it's the same. The code, the base code is the same. It's just different annotations. That's it. And now let's look at the reactive part of how Micronode does this. It looks still similar, but because it's reactive, we have different kind of response. Micronode is a little bit more low level from the implementation, so feels a little bit different. But at the end, the basic is always the same.
Yeah.
Emily?
Yeah. So that's about REST, and since we said at the beginning we want to concentrate on this REST access and database access pattern, let's have a look at how you can use the 4 frameworks to access a database. And don't worry, we don't want to show now all the functionalities. These are just the 2 ones where we want to show some code. And what I do here is I start with Quarkus. And so whenever I try to access a database, which mostly fails when I do it, but whenever I try to do it, I use the repository pattern. And so what I did is I tried to implement the repository pattern for all the 4 frameworks. And so I assume most of you know the repository pattern, that you have a class or an interface that is a facade to the database access for one specific entity, and that contains the method to interact somehow with the database regarding that entity, like deleting it, storing it, updating it, finding it, and so on. And again, we have the movie example here. What we want to do is we want to find a movie by a name. And Quarkus has something which is called Panache, that is based on Hibernate and then therefore based on JPA. So the entities that we are using here are based on the JPA specification, so on the Jakarta E JPA specification. And they provide this Panache repository API that let you easily create classes based on the repository pattern within Quarkus, with a nice fluent API, like you can see here with this find name dot first result. that let you create queries to find, update, manage your entity. In Spring, it's even easier. So whoever used Spring knows that Spring can have a lot of magic, and sometimes it's important to understand what this magic does, because otherwise you can run into horrible pitfalls. When talking about the repositories, this is quite nice, again, the magic, because in Spring, the repositories are always interfaces. You never need to take care about any implementations. And the magic goes really that far that for some requests, you only just need to define your method like we do here. So we have a movie entity that we maybe get back. So we define it as an optional and we put in a name. And Spring knows what to do with this name parameter by the name of the method, which is find optional by name. And by this by name, he knows that he needs to search for the name field. So this is really a lot of magic, and this ends really in, not much code that is quite good readable for all these basic patterns. It's similar in Micronode. Again, we have an interface, we have base interface classes, which is here the CRUD repository. And again, we can create a method like find by name that let us, just return our movie entities and find them in the database. When using MicroProfile, it's not that easy because the MicroProfile does not provide any APIs or functionalities regarding the repository pattern. So the MicroProfile only has JPA. So, I mean, for most people, that is definitely enough, but this means that you need to use the JPA API to create the queries on your own. And here you just see an example how the repository pattern can then be implemented by using the MicroProfile and then internally using the Fluent API of JPA to create and execute the queries within the repositories. So these are just two examples, the REST access and the DB access that we wanted to show you how they look like in the 4 different frameworks. And as you might have seen, it's quite similar, right? So there are some that are better than the others, but at the end, none of the code really looks complex. There is no problem in any of those, so any can be easily used for this use cases. As I already mentioned, there are more frameworks next to the 4 that we looked so far at, and we will have a look later on when talking about Docker. I just want to show some additional frameworks that are out there. One is Heavydom, or Heavydom. It's a framework that is provided and created by Oracle. It's an open source framework that lets you create Java microservices too. And the special part on Heavydom is that Heavydom is splitted in 2 different frameworks. There's an Heavydom SE and an Heavydom ME edition part, however you want to call it. And the interesting thing is that the one or the Heavydom ME is based on Heavydom SE. Heavydom SE provides the Fluent APIs that you can use to create small services that have HTTP access, that have just REST endpoints. So you see an example that just defines the /create endpoint for the HTTP GET method that will return the hello world string once a request happens. And Heavydom ME is based on the Heavydom SE frameworks, but implements the MicroProfile based on this Heavydom SE framework so that you can use the MicroProfile APIs within this Heavydom ME. Another thing, if you really want to create small HTTP services, is Spark or Spark Java, which is a framework that I really like a lot, because this is really just one jar that lets you easily create an HTTP server. Here we see the whole Java code for the application with all the imports, with the main and so on, that creates an HTTP server that has 2 endpoints, one /hello that just returns hello world, and another one that already has a dynamic parameter, the name, and that already returns dynamic content. And this is really great if you want to test something, if you want to create a small service quite fast, or even if you want to write tests. So I used Spark a lot, for example, to just create some small fake services that I can then call from the services I want to test to. So this is quite nice. And next to this too, there are a lot of more frameworks like Verdix, Turbox. And yeah, you can even take things like REST Easy or Jersey and define them as frameworks for MicroProfile, because you can use them to create a small service that can be accessed by HTTP and do something. So since there is no, I don't know, official microservice definition or manifest, at the end, in theory, you could say, you don't even need a framework. You can do it with Java because you can open a socket. But yeah, this is just a list with some frameworks that you can use. And next to the general functionality that you need for microservices, like, as we've seen, database access or HTTP, one core concept of microservices is, or why we even have microservices, is that microservices should be scalable, should be deployable in the cloud, and so on. Yeah, I just see there's a question regarding alternative protocols like Swift or gRPC. We will come to that. Yeah, you can say something, Karsten?
I know, for example, for gRPC, there's a good support in SpringBoot. This is what my current customer has rolled out for all the microservices. They are all SpringBoot based, and they come always with gRPC support out of the box. And Thrift, I don't know about that, but it's Thrift is quite easy to implement and integrate as a library. So I do not see a problem to provide endpoints that support Thrift as a protocol.
Yeah.
But they, if they are coming out of the box with that, I'm not sure about that.
Yeah, me too. But that's a nice question, because we always correct what else can we add to this presentation as points that we can compare, and adding, for example, like something like gRPC might make sense. Thanks for that. But as and Heavydom offers directly gRPC support. Because we have someone from the Heavydom engineering team at Oracle in the audience. That's great. Hi, Tim.
Don't let us say something wrong here.
Anyway, as I already mentioned, next to all this, what is important for microservices is the scalability, and that you can deploy them easily in the cloud. And since some years, we have a quite good tooling to do so, which is Docker, right? So what we want to do next is we want to have a look at how you can deploy applications that are based on those frameworks in a Docker container, how you can create Docker containers out of it, deploy them in the cloud, how fast they are, how big they are, what different kind of options you have to structure such Docker container. Okay, the most easiest thing that you can do is something like this, right? So you take, you create a Docker container. Here we just see the Docker script for a sample. And what we are doing here is we depend on a Docker container that's based on Ubuntu and has a JVM that we all love and want to know, which is adopt OpenJDK and in future Adoptium in it. And what we are doing now is we just deploy our fat jar that contains our full microservices with the business logic and the framework. to the Docker container, export the HTTP port, and then just start our application. And when doing something like this, you can think about having 3 layers in our Docker container. First of all, we have the operation system, which is UX-based. So here we have an Ubuntu, a Linux. Then we have the JVM. In this sample, it's Adopt OpenJDK, a Java 11 release. And we have our application. Once we've created such file, we can build our Docker images by using the docker build command. And once the image is built, we can easily start it by using the docker run command one time or as many times as we want. I hope this is clear for everyone, because yeah, if there are any specific questions based on this, just ask them to the chat or now, then I can go a little bit deeper to that. Otherwise, I assume that this Docker basic is clear for everybody. So when executing those commands and when having a look a little bit deeper into the Docker logging, you will find something like this, which is the list of commands that are executed to create the Docker container. And this is a little bit cryptic for now, so let's make it more clear, and first of all just remove some lines we do not take care of. Now we have like 4 lines. We see a size that or the size difference that is based on those lines that are executed in the Docker container. And when having a look what this line does is, we have one line that sets up the Linux basic layer. Then we had one line that installed some basic Linux tools and does Linux updates. Then we had one line that downloads and installs the JDK. And then we had one line that just copies our jar that contains the microservice framework and the business application. And yeah, in general, based on this, we see again our 3 layers that we've even already seen before, where we have the operation system, in this case Ubuntu, we have our JVM, and we have our application with the framework. And as you can see here, I mean, we will have a look how we can make this better, right? But with this first approach, you can already see that the microservice with the framework is by far the smallest one, right? So in this case, everything else is way bigger than our application. We did a small application, right? We do not added tons of images and data and I don't know into our application. So this was really a small microservice that we created here. And Karsten, you wanted to say something, or?
Yeah, I just want to say that just to know that what are the 17 megabytes for the application about. This is the most simple microservice that you could build with Spring Boot. So it's just what comes out of the box with a hello world.
Yeah.
So when you compile that, you have 17 megabytes of application.
Yeah. And when doing this with the different frameworks, at the end you will be somehow here. So Spring Boot is the biggest one, but as you can see, they are more or less the same, right? So we have 10, 13, and 16 megabytes for this Hello World application. So there is no big difference. If you really take care on each megabyte, Quarkus is a winner for sure. But if you do not take care about that, you see that the operation system and the JVM is much bigger. But this is just the plain first example. And now we can take this one, play with it, make it better, make it faster, and try some different options. And you might ask yourself why MicroProfile is not mentioned here. Because as we already said, MicroProfile has this application, so it's not really application, let's call it runtime approach. And if we compare each runtime, we would have, I don't know, like 10 different runtimes here. So we have a specific slide for the MicroProfile that Karsten will show you later. But first of all, I think, Karsten, you want to say something about GraalVM support.
Yeah, all right. So for GraalVM, that's a very, very interesting approach for running microservice, because you can compile an application to a native executable, and this application will become much smaller and much more faster executable than you would do it with a normal Java stack. The different microservice frameworks try to complete this a little bit by partially having support for snapshots, that they remember the state in which they were started, and they just boot like you would do it with a virtual machine from a snapshot, so to have a much faster startup. But when you have just a native executable and not many libraries in there, this is of course much faster. This comes to a price, and the price is first compilation. So the build time is much slower. We showed this here. When you build, for example, a Quarkus application for GraalVM, then you take almost 2 minutes to compile the most simplest application on this was measured on my MacBook with i9 processor, so quite a fast machine. So really slow build times, and larger the application becomes. This does not make fun, and usually would just say, okay, let's make a build server which does that job, where I really don't care. On the other side, we get rapid, fast startup times. So you see, okay, this service will be ready in a fraction of a second. I was starting writing server-side applications with IBM WebSphere, and the application at that time took several minutes to start up the most simple thing, and this was quite a hell. The application that comes out of that, it's it is larger than the normal application for Quarkus, but it has everything inside. That's the nice thing. So we have a 30 megabytes layer for the most simplest application, but we do not have any layer for the JVM anymore. We just have the basic Linux layer and then the application on top. That's quite nice. And now we come to MicroProfile, which makes it a bit special from the aspect of layering, because as we said, we have standards and usually have some kind of container, which like an app server like OpenLiberty, which implements it, and we just deploy the application on top. So the application layer itself is very, very, very small. So you have to take this into mind if you build an application commit per commit, and have to store that. So for a SpringBoot application you would build a layer of 17 megabytes with each commit, and this for the most simplest application. With MicroProfile, you just build the REST service, and it's just a single Java class that is packaged into a jar. That's almost nothing. Okay, 17 megabytes is not much, but the real application that you would build is much larger. In my current project, we have over 100 megabytes, which is a microservice. So which raises the question also, what is a microservice in Java, and what is a plain old big application? But we see the application layer here in MicroProfile is really, really small. And if we could come to next, we took a look how fast the other servers did start. So what we measured here is we start the application until it first answers to the endpoint with "Hey, hello world," and we were quite confused by Pajara that it took almost 60 seconds to serve the hello world. So think about a cloud environment where you deploy the application and you want to start up a pod fast, and it ramps up that much time. So Yeah, that's quite slow, and compared to the others, yeah, much slower. But the others are almost roughly similar. We see Quarkus is the fastest here, which took only 2 seconds, and SpringBoot in the middle, and there we have here something in between. OpenLiberty is quite fast here, but to the cost of build time again. So it's often the payoff between build and startup.
Yeah, I'm just checking so one thing we can say is that Quarkus is not the only one that supports CryVM, right? We just took this as an example, and today a lot of, I mean, there was already the question about Spring Native. Another thing is Heavydom that has support for CryVM. So we just put this here as one sample where we use CryVM to compile and run an application.
Yeah, but maybe why is SpringBoot not there? That's one of the specifics of the applications that are built on GraalVM is that you can't use reflection, or you have to do a lot of configuration to make reflection work on applications and with GraalVM. And Spring is heavily relying on reflection, and that's one of the reasons why it's quite complicated to make a SpringBoot application run on GraalVM. It's not impossible, but with the other frameworks, they were built up front with that support. For Quarkus, for example, they have a lot of extensions, and basically what these extensions do for different frameworks is they describe also the metadata that is needed to make it run on a GraalVM. So that's where the focus is slightly different. So it's basically possible. It's just not fun to make SpringBoot applications work on GraalVM. And then I would choose other frameworks if startup time and memory consumption is it more important than convenience in implementation. So can you please advance?
Yes, this is already the next one.
Sorry. You switched up. Yeah, and now the build times. Yeah. So how long does it take to actually build applications? And as said, when you build for GraalVM, then you are doing heavy stuff and takes quite long. And here, SpringBoot was the fastest, and OpenLiberty, I said, okay, the startup time comes to the cost of the build time. So here you have the payoff. But luckily, often you just leave the build service do the build, and you do not actually care if it's taking 2 minutes or 5 minutes, and unless you do not have to do this locally. But for local development, of course, turnaround times are very important, and you do not actually have to run the whole build to develop these applications. But let's come to that later.
Yeah. Okay, so coming back to the size of the Docker container. So at the beginning, we have seen that when you just use Linux and a JVM and then the application, how big that is, then we've seen there are some differences with MicroProfile, and when using CryVM, since you compile like JVM and the application to a native build, this is quite small. Another option that you have to create smaller images is, for example, by using a JLink, which is a tool of Java, which is part of the OpenJDK since Java 9, and that you can use to create custom tailored JVMs like for your specific needs. So what you can do with JLink is you can create a JVM that only contains the part of the huge full-blown JDK that you need to execute your application. And next to this, there are operation systems that are way smaller than, for example, in Ubuntu. And based on this, you can create applications that are, or not applications, you can create Docker containers that are way smaller. So one thing that you can use is you can use this Alpine Linux, for example, and you can get an Alpine Linux where a Java application is running on down to 10 megabytes. And next to this, you can create a JVM with a small Java application that is executed. I mean, if you're in your application, you use, I don't know, a Swing to render images in the background that you then use to show them at a REST endpoint. And next to this, you use a Java logging, and you use, I don't know, what else, SQL, and so on and so on. It will become bigger, but if you really have a small application, you can, for example, get your JVM down to 55 megabytes. So the application it will be the same size, right? In this moment, I've just put here 47 megabytes, but the application don't become bigger or smaller by using this. But what you can use is you can use another operation system, and you can use JRing to get the size of the JVM smaller. But adopt OpenJDK, and it's not that much a problem with OpenJ9, because at adopt OpenJDK you can download OpenJ9 builds. But to be true, we don't use OpenJ9 here. We used a hotspot-based JVM. But with OpenJ9 you can even do more tricks with this shared, how is it called? This shared class loading memory, I don't know, where you can even create smaller containers since class loading is shared between instances. But I only heard about that. I never did it. So but there are more possibilities, like using even optimizations from OpenJ9, for example, to make it smaller. At the end, you have different scenarios, and you have different things that you can do, right? If you just want to create an application, deploy it somewhere, maybe have a replica to be sure that your application is always up and running. Do whatever you want. Just put your application in an adopt OpenJDK Docker container. Then it's 400 megabyte or whatever big. That's totally fine. That is not a problem. If you have a lot of applications, then maybe the size is important for you. And if you release often, like once a day, then even the size of the Docker containers is important for you. Maybe then something like MicroProfile is a good choice, because then the difference between the containers is very, very small, only some kilobytes. Or you use JRing to strip down the JVM to lower the size of your containers. Or if you, I don't know, Netflix and scale up and down the whole system every day and add 1,000 containers and kill 1,000 containers per second, then it's very important to have a quite fast startup time of the containers. And in such a case, using Cry4M, for example, is maybe the best choice for you. So again, all of the frameworks have good opportunities here, have good functionalities, and there is no silver bullet that solves everything. So it's up to your use case what will be the best thing. So yeah, that's about the Docker compiler support and how you can put such applications in containers and into the cloud. And there are already some questions regarding, for example, gRCP and other things. So as we already mentioned at the beginning, there is just no chance in such a session to look at all the functionalities that the microservice frameworks offer and compare all of them. So there are a lot of additional features where it would make sense to have a look at, for example, security. What kind of security functionalities do they offer? Other things are tracing and monitoring. How easy is it to monitor my application? How easy is it to create a trace maybe over several hops? How can I configure my application? Do they support some kind of cloud configuration where I just store my configuration file somewhere in the cloud and they will be loaded automatically? Service discovery. If I have a lot of services, I do not want to put the IP address of each service at all the places. So it would be good to just name the services and to talk to a named service. What else? Serverless functions. So some of the frameworks already support a serverless mode where you can create serverless functions based on the framework instead of creating this big microservices. Another thing is reactive APIs that become more and more part of all these frameworks. So all the things we haven't looked at in this presentation, but as said, that would be then maybe a day or more workshop to have a look at all those. In general, so I mean, we have not looked for this presentation to those. So we already did a lot of these things with a lot of the different frameworks we have seen. And in general, it's like the other parts we've seen. They are already good. So the framework supports such functionalities. I mean, have a look at monitoring, for example. There is already a MicroProfile and API. Same for security. So you have that functionalities, and in general, none of those will be a show blocker for one framework or another one. At the end, it's the mix of the features and that makes one framework maybe better for your use case than another one. Okay, that's it in general, but we prepared kind of conclusion to this comparison between the frameworks. And yeah, let's have again a look at these four frameworks. So Quarkus, MicroProfile, Spring, and what have I missed? Micronode.
Micronode.
Yeah, thank you. I don't know, Karsten, do you want to say something, or should I do?
Yeah. So at the end, yeah, there's no clear winner in that. In any case, it is they're basically all very easy to use. They have good documentation. They have good support. They have big community. But maybe we should a little bit pick one of the sweet points about each of the frameworks. And for example, if I take Quarkus as an example, what really shows up there is the joy of development with Quarkus. That's completely different from the experience like you have it, for example, with SpringBoot. In a SpringBoot application, you have to start the application up, then you develop maybe something breaks, you have to stop the application, compile it again, build it again, start it up and test it again. That's completely different when you work with a Quarkus application. Like I said before, it's like developing a JavaScript application. They have managed to build a system based on Maven. You start just the Maven process, and it's always running. And you just write Java code. It will be immediately compiled. It will be immediately redeployed, and your application starts up again. And you do not have this fraction of stopping the application and starting up again. And this makes it really joy to work with that. Also, the APIs they're quite similar from the joy of use, like in Spring Boot. It's just that that the Spring framework is more well known to Java developers. So if you ask nowadays, what microservice framework you use, you possibly will find persons who just say, I'm using Spring Boot. but you really should have a look at Quarkus in that case. And I think also, MicroProfile has a really sweet spot. I think that MicroProfile has a little bit a problem with marketing, let's say. If you think of MicroProfile, you immediately think of Eclipse, because it's Eclipse MicroProfile. Eclipse is that, and you also think about all those heavy application servers and the big vendors which are in behind, and OpenLiberty is basically WebSphere, and you have Wildfly, and which is basically JBoss, and you think of these big application servers, and that they are heavy to understand and to maintain, and slow startup times and so. And that's completely not true. These application servers or these containers or container platforms for MicroProfile have been built with the background of supporting microservices, and they are completely modular. So you can build your customized version of OpenLiberty, which just supports certain parts of the specification that you really need. And the same for Wi-Fi. You can make a custom implementation out of that, and the startup times are quite fast. What is really a plus is documentation. You find tons of documentation about how these container platforms really work, and that's big plus. And what we also said is about regarding Docker support. The application layer is almost nothing for those kind of applications. So I think in that regard, MicroProfile and the platforms that they are operated on are completely underestimated in the minds of developers. And last but not least, we've chosen Micronode as a small application framework, which has some sweet spots in terms of size. It's a very small framework, and it's also quite easy to develop things that you typically need for building the microservices that you usually use, like our example, like with REST front end and some database back end. That's quite easy to do that with that. And you have there out of the box this reactive support, which is also different from SpringBoot. Also, they are providing reactive libraries, but it's built on top of SpringBoot. So you have everything from SpringBoot plus reactive, and it feels not that it's built with that in mind. So all the frameworks have their sweet spots.
Yeah. So what we did at the end, but I think we do not now need to go through line by line, but you can have a look at the slides. We put a comparison at the end where you see okay, the license, who's the owner of it, when does the application develop or the framework development starts, do we have maintenance releases, and so on what specifications or maybe not specifications does the different APIs, like for REST, for dependency injection, and so on, based what Java versions are supported. Regarding containers, how is the start and build time, how is the image size compared to each other, and so on and so on. So more or less everything we already talked about in a nutshell. As I already mentioned, there are a lot of things that have not found their way into this presentation next to additional APIs and functionalities. There are some other things that are interesting, like the memory footprint, CPU usage, scalability. We already had a look at Docker containers, but maybe for some professional support is important. Then if there are some Kubernetes or cloud APIs that you can directly use to interact with other services or other tools that are out there, if you have some IDE integration that let you create classes like model view controller constructs or repositories, data repositories, things like that. Yeah, but at the end, as Karsten already mentioned, there is no clear winner. All have their benefits. I think most people have one of those frameworks that they like more than another one. You heard Karsten talked a lot about Quarkus and MicroProfile, for example. So it looks like these are the one where he normally likes to work with. That I don't know.
No, that's not necessarily. Actually, I'm just working with SpringBoot at the moment, day by day. But this is because that's how the customer works. And I completely understand to write applications with Spring Boot. It's so easy, and everyone can build big and great applications with Spring Boot. It's just that I wanted to point out the others are really worth to have a look at, and they have benefits which the people that just say, okay, Spring Boot is best, do not see.
Okay. Yep, I'm totally with you there. But anyway, so that's it. What we have prepared for today. I hope you liked it so far. I see clapping hands from Mary. Thank you. So if there are any additional questions, just ask them. That would be great. We answer as much as we can. And so both of us are registered at the Discord, right? So yes, if you have any additional questions later, you can just ask them at the Discord, or you can just ask. I think the easiest way otherwise is ask us at Twitter. So we are both at Twitter. I've already closed the slides. No, I have not closed them. We cannot share the slides.
Oh, thank you, Matt.
Thank you. Yeah, that's true. If you have questions later, Matt. I'm sure. Yeah, and I'm sure too. Sometimes I have questions afterwards, after I think about it, because as such, it is a really heavy topic and so enriching, right? So many things, and you cover so many things, and you cannot possibly get into every single, kind of aspect of it. But yeah, certainly we will be having questions as we're digesting all of the materials. So feel free, join our Discord. I'm trying to actually look for a Discord link. I should have opened it, but when I find it, I'll post it here. But then, in the meantime too, I think if nobody has any more questions, then I like to do our
there's one question from Brian.
Brian.
So Brian asked, what kind of standards are needed for MicroProfile to be part of it? Depends on the version. Starting with MicroProfile 1.0, they said, we just need the very basic. I'm not sure which standards were in there, but it was definitely JSON-P. And what else? I actually do not know. And specific version of JSON-P. And then they said, okay, now let's add maybe fault tolerance and CDI was also very, very early in the MicroProfile standard, so dependency injection. So that's basically what you need. You need the REST API, so jumpstart was also there. Serialization, dependency injection. This was the very basic where the MicroProfile started, and with the current specification versions at that time. And then they built up one by one and said, okay, and now let's upgrade this standard to that version and put another standard on aside. And that's now MicroProfile 1.1. And nowadays, we have a set of 12 standards, which makes up MicroProfile 4.0. And you have standards like fault tolerance, metrics, and health, and tracing, and all those things that you security, of course, and and such things that say, okay, this is the standard what a microprofile 4.0 runtime must fulfill or must potentially fulfill to call itself microprofile 4.0 compliant. But of course, they can offer much more non-microprofile standards.
Okay. Thank you.
I hope I gave this correctly, Mary. So you are the expert on microprofile.
That's right. Yeah, thank you. Yes. Yeah, I don't want to it seems like shameless plug, saying that, go to microprofile. So, but I'd say, yeah, microprofile is pretty comprehensive, the whole, support of all the standards. So, yeah, but thank you. Yeah. Okay. And do we have any more questions or for Hendrik and Karsten? I'm trying to make sure I don't miss anything too, right? Thank you again, Hendrik. Thank you again, Karsten. Thank you to everyone who joined us today. Yes, this has really been a great, the content-wise, everything, and the atmosphere. So thank you. We actually have a lot of folks who joined today. That was really nice too. Hopefully too, yeah, everything is going to turn better now, and we can go back to in-person meetups. Hopefully, maybe Q4. But yeah, so when Hendrik and Karsten, we can travel again, we'll invite you to come to Chicago. So thank you so much. Yes, yeah.
Perfect. Okay.
Eat dish, authentic Chicago, 1,000 calories pizza. So yes.
That sounds good.
Yeah.
Perfect.
Yeah.
Thank you.
Yes,
Okay.
Thank you.
Good.
Thank you. All right, then.
See you.
Yeah, if you
Okay.
see you. Yeah, thank you. And if anybody wants to still hang around, please feel free to do so, or go to the Discord. It's on all the time, and anybody can join. It's asynchronous style of communication. So please feel free to join us. So thank you. Have a great day. Take care.